It's a pleasure to be here. It's always interesting to meet new people, exchange ideas, discuss, debate, dialogue. And so just the opportunity of being here amongst you, amongst colleagues in Iceland, people of Iceland, meeting some of the panelists for the first time. I'd heard of them for a long time, so it's always one. I travel a lot for the work I do, and every time there's something new and surprising and interesting, and so I love doing this kind of work. I always call myself a global nomad, because in my younger days when I was growing up in Africa, I grew up amongst nomadic people. My father worked in the army on the border with Kenya, Ethiopia and Somalia, and there were lots of nomads going back and forth as they had done for centuries, millennia. And I ran around with them. There were no schools in those days, and I think until about 12 years old, then my parents caught hold of me and sent me to school, and that's when all my problems started. But here I am. So today, let's talk a little bit. There's a lot of material here, and a lot of this is available for easy access at your leisure, so I won't show you everything. It'll mean I'll have to do about 150 slides in 30 minutes. It has been done, but I won't attempt it here. Just present to you, I think, why we did this report, Turn Down the Heat, as Gudnig introduced. Why is it important for the World Bank to do this? So what have we done? Who's done it? What have we found? And what are we doing about it? So what is the key question I want you to keep in the back of your mind. There's a lot of science, there's a lot of information and knowledge that's coming to our attention almost every week. And often decision makers, policy makers, individuals like yourself, communities across the world are dealing with this on a weekly basis. And are demanding answers, are worried about the future of their children, and are now increasingly worried about their own futures, as we will see. So thank you for participating in this event. I think basically we are now at about 0.8 degrees centigrade warming compared to pre-industrial times. And the other day I was talking about this number, and often for the people, the communities that we talk with, the politicians that we talk with, numbers mean relatively little unless you can make it meaningful in a daily context, and especially policymakers. So the 0.8 degrees centigrade, and you think in centigrade, so I'll stick with that, represents an anomaly of a global mean. So if your body temperature across the world, well not yours, but if human body temperature across the world is 37 centigrade, an anomaly of 0.8 is okay, is within the realms of variability. If we're talking of a plus 2 degree anomaly on 37 centigrade, you have a high fever. If we go to plus 4, you're in a coma. So that's the sort of relevant range of impact that we're looking at, not just at the body level, but in our ecosystem level. So as Gavin highlighted, a 4-degree planet is a different planet. We won't recognize it. A 2-degree planet is no picnic, if you want to remember that little phrase. This is something I use often. Because at 0.8 degrees already we're seeing some pretty major perturbations to our livelihoods, to the climate system, to the weather system, and to the ecosystems. Okay. I'll try and relate some of this to the area where we are. Even before we did the report, we had this. We started to see data becoming available of the rapid loss of Arctic sea ice. Greenland, at one stage, 97% of the ice sheet, and at least the surface, had thawed. First time that had ever happened. Okay. Ocean acidification, people who are measuring it started to see significant rise in ocean acidity. If you think in the units of acidity, that's pH. You can see the blue line there at the bottom, or the red line at the bottom. It is red, right? Yeah, is declining. So that's bad. That's really bad for shellfish, sea-dwelling organisms, coral reefs. We were seeing that starting to happen. In 2010, we had that massive heat wave in Moscow. You remember that? It almost produced a nuclear accident because they had to abandon, in the fires that ensued, they abandoned one of the nuclear power stations that was not far from Moscow, and there was a risk of that fire sort of impacting the nuclear power station. It was quite devastating. But interestingly enough, what happened in Russia was also linked to a simultaneous event that happened in Pakistan. So it's not just, you know, what happens in one place stays in one place, as Gavin said. You know, it's if you look at those waves there, it's really interesting. You're looking at the jet stream here in the lower right-hand side, and you can see where Moscow is on the top, and you can see where Pakistan or Karachi is in the bottom. And basically, if you look at the top here, this bulge in the jet stream brought in hot air and gave the heat wave, and sucked in cold air and moist air and gave the mega flood in Pakistan that impacted 2 million people. These were essentially in a similar week, back to back, almost within the same period. So we are highly connected. It doesn't matter where we are in the systems, as you saw that lovely animation that Gavin put up. Okay? Now that was a satellite view. Here's the reality. Okay? Something similar happened during Superstorm Sandy. The jet stream actually blocked the progress of that hurricane, and normally that would have gone out to sea, and instead, because of the jet stream blocking, it actually turned left and impacted New Jersey. Now, all the climate models or the weather models were predicting that the hurricane was going to go out. Luckily, NASA had a polar satellite that said, it's likely to come ashore at New Jersey, and I gather they predicted within a kilometer where that was going to happen. And so immediately they called the politician and said, you see, we've been asking you for money to put these polar satellites up, and you haven't. Just as well we had one up, because I think there was a very... So the other thing that we were seeing was this issue. This is the paper by Tim Lenton, Sheldon Huber et al., talking about tipping elements, these big tipping points in the global ecosystem. And they identified several. You know, there's a lot of debate about this concept of tipping elements, but it alerted us in the World Bank that the connectivity of impacts could have major development implications for the communities and partners that we work with. So as an agency that works in development, we were particularly concerned that we start to actually gather the information, the science, the scientific evidence that might highlight where these vulnerabilities are across the world, and which particular biome might we begin to see this kind of impact, and would that then generate a cascade of impacts elsewhere. And so here, very quickly, you can see the polar melting is highlighted as one tipping element. The circulation change, both in terms of ocean currents and monsoons, is another. The Amazon biome pops up, you know, as a major tipping element. You know, you can read this at your leisure, but I think I wanted to use this because this is something that triggered alarm amongst us as development practitioners. I should have said that I'm one of the few scientists in the bank. I'm not an economist. I think we have more economists per square meter than anywhere else in the world. They are very clever people. And I often tease them because I said, so how come all you brilliant economists didn't pick up a single financial catastrophe in the last decade? And I get shunted out of the room when I say that, so I have to be very careful. But it's a good-natured debate that we get. So as a scientist, I can risk certain things. And they say, this is one of the oddities, you know, so I'm tolerated. Anyway, very quickly, so what does this turn down the heat series do? It looks at the biophysical climate change impacts in different regions. What are we try and sort of tease out what are the crucial development impacts triggered by the biophysical impacts that Gavin was talking about, that Kevin will hammer as well. Looking not just at the physical, biophysical, but what are the social ramifications of these changes, because they're going to be very, very big. It's going to trigger massive social impacts. And we wanted to see if we could then start to tease out impact cascades. Always understanding that there is probability, there are probabilities involved, there are huge uncertainties. We need to sort of be careful about what we sort of say is going to happen or isn't going to happen. Nevertheless, we are getting pushed by our partners in developing countries to say, hey, you're helping us to do investments in infrastructure, in health, in education, in agriculture, in forests, in water, in hydropower. We need to be comfortable that you have this long-term vision, because a lot of these investments are 40-year, 50-year lifetime investments. And so this is where we are. We're trying to take this very high-powered science and try and make sense of it in terms of development. Understanding that there are uncertainties and still argument about where some of the directions are of change. Very quickly then, where does humanity, we know that CO2 is contributing to global warming. There's some people who still claim that it isn't, but this is where most of the CO2 comes from, about 90% from fossil fuels and cement. 10% is about from land use change, deforestation, agriculture, etc. Where does that CO2 go? 50% roughly into the atmosphere, about 25% into the land, forests, and the rest goes into the ocean. As somebody who works in agriculture, forests, climate, I often say that, okay, we're 10% of the problem, but potentially 25% of the solution. So this is how I try to argue my economist friends as to why agriculture is important, why forests are important, because these are sort of almost esoteric sometimes in the highfalutin economic discussions that go on. But it's and then I often sort of highlight this. There's disagreement among scientists, right? So this is what disagreement looks like. Okay, and these are people who are working with numbers. So I think that's important to sort of show. This is also showing that really for 650,000 years, atmospheric CO2 have never been higher. So 1950, there on the right, on your right, you see the sharp rise. When I did this graph, when I tried to put it in a PowerPoint in 2013, it was 396. I just Googled CO2 now. This morning it's 399.85 as of the end of January. Okay. My daughters continuously track this and give me a hard time at breakfast. What are you doing? And here's the number. This is another sort of summary that we use. 3 major global surface we've just seen, show that Earth has warmed. Most of this warming has occurred since the 70s, largely. 20 warmest years have occurred since the 80s, and all 10 of the warmest years occurring in the past 12 years. So we have some very dramatic sort of evidence that something is changing, and in terms of at least the warming. If we look at the 11 key indicators in a changing climate system, roughly all of them are moving in the right direction. If, as we postulate, climate change is happening and is beginning to impact. There is this argument going on about the hiatus. Why hasn't warming picked up recently? Why hasn't it flattened off, etc.? But other scientists are taking a hard look at it. I understand it as almost a cherry picking. You look at the decade or two, and you see a flattening off. And if you look over the period that we were looking at, you can see there's levelings off that have taken place in the past as well. So I wouldn't throw away all that data just because in the last decade we've had a hiatus. That's my simplistic approach at it. But Gavin, Kevin, and others here who know the science much better would happy to. So quickly, we are at 0.8 centigrade above pre-industrial. Oceans have warmed too, not that much, but that's pretty significant for oceans because there's a lot of water. Sea level rise 15 to 20 centimeters since pre-industrial time. Doesn't seem a lot. If you go to the beach or you're familiar with the sea, 15 to 20, you're barely around your ankles, right? While on the East Coast, when Hurricane Sandy hit, the wave height that came in was at 15 feet, with probably slightly more than this level of sea level rise, because that was combined with a storm surge, and that was combined with a high tide. The full moon was up, and it basically inundated New York subway system. That was a huge cost. Salt water and electrical systems just don't work. You know, it's just a mess. And Michael Bloomberg, who was a mayor at that time, got really upset. He says, how come? This is New York. You know, it's not some little village somewhere. And how come we are exposed to this kind of problem? And it came about a week after we launched Turn Down the Heat 1. And the week after Hurricane Sandy hit, Turn Down the Heat 1 got like 25 million hits. It was quite amazing, you know, people, it certainly focused the mind. So Bloomberg picked it up, Trump picked it up and trashed it, but he picked it up and he tweeted it to his million-plus people. Gore picked it up and tweeted it. And so we had incredible, it's still getting hits. For a report that was produced for an internal audience with about $30,000 and delivered to us by PIC in about 6 weeks, it's been unbelievably successful, beyond our wildest dreams. It has raised awareness, and for the first time the president of the World Bank actually signed off on it. And his words were, well, if there's an alarm bell ringing, we better not sleep through it. And if the science evidence tells us that something has happened, then we cannot discard it. Doesn't matter what your personal opinions are. So that was strong enough for him to sign off on a major report that went public. It wasn't a report that was published by undertaken or produced by the bank, but we had partnered, as Whitney highlighted, with a very renowned climate agency. So what's the future? So I mean, you see this kind of range. We're currently at 0.8. We're likely, if we are very lucky and with huge effort, and I don't want to upset Kevin because I know he's in the back. Looks like we've already passed it, but I mean, maybe there's a technical possibility that we could stick it. But we have to stop all emissions, I think, tomorrow. You know, and that's not going to happen anytime soon. So you know, it looks like we're headed for 4 or beyond. And that Turn Down the Heat first report sort of showed we can expect hotter summers really globally based on this map. Unfortunately, the effects around the tropics, where most of the developing countries are, that have contributed relatively little to these problems, will be hit harder. So that's ironic. You know, you haven't really been the cause of this problem, but you're going to take the bulk of the damage. And this is something that is important for us as a developing agency to understand. I won't bore you with these figures, but this is part of the science that Potsdam and others are using, and everybody uses, IPCC uses, and basically shows where it is that we have to stop emissions if we want to stay below 1.5 or 2. That's that line, and see, even if we were to stop today, there's enough inertia, geophysical inertia, that, you know, we'll still for up to the 2100 will still be up there. It's not going to, the temperature isn't going to drop. Okay, and now recent papers show that emissions today, in essence, result in an impact in less than a decade. So if we are emitting, we feel the impact, let alone our children and grandchildren. And I think this is the other important thing. Sea level rise projections, we see that it's not showing up very well here, but in essence, as you see in the title, you know, they're tracking at the upper limit of all our projections. And that's very worrying for many of the coastal areas. Why? Because we are increasingly urban globally. Latin America is the region where I work most. We're 70% urban, and it's going to be even more urban soon. East Asia is 45, and more of them, and they're all coastal megacities. So we have a problem, and if sea level rise is going up, you know, we have a problem. The coral reef story is pretty devastating, really, because we're talking at 1.5 degrees. We're not even talking 2 degrees. So all indications are that 1.5 degrees, we'll be lucky if 10% of the corals globally are alive. And you know, if we go beyond 2, then there's no coral reefs, basically. That's what we're saying. And this is why the small island states, or SIDS as they call them, have been clamoring for a 1.5 degree threshold. Not a 2 degree, a 1.5. They've been clamoring for this for a long time, but they're small, they're politically not so powerful. We love going to their beaches, but apparently, you know, they're not that important when it comes to some of these threshold discussions. But nevertheless, this is, you can see here, as we go down, even by 2 degrees, you know, it looks red all over. That's not good. Fortunately, nowadays you can use the color red without being labeled politically, right? There used to be a time when you couldn't. You had to be careful. Anyway, again, agricultural productivity. Again, we see this southern hemisphere impact. Australia is linked in with us. The Australian Prime Minister is having a hard time explaining why he, doesn't think carbon and climate change is important. But the Australian farmers and farming community and scientific community are extremely active. But basically there's a lot of data here showing crop trends. The point to focus on is this one. What we're seeing in the literature is that a potential yield loss of about 5% for each degree Celsius of global warming. That is highly conservative based on what I'm seeing in the field. The work we've been doing in Latin America and Brazil, Argentina, and other places suggests it could be as high as 20-30% by 2030, because we're having cascading impacts. It's not just temperature thresholds, it's not just water. We're seeing pests that we've never seen before. People are sort of spraying left, right, and center, and you can imagine what happens when you do that. Bee population, pollinator populations are disappearing at an alarming rate. And so we're beginning to sort of get particularly concerned. That's, a fairly conservative figure based on literature, and that's important to note. It's based on peer-reviewed literature, so this is what we're using. The urban impacts are large, especially temperature, and as humanity becomes more urban than rural, this is the trend everywhere, especially in informal settlements in Latin America, in East Asia, South Asia. These the people who settle in peri-urban or even urban areas don't have access to air conditioning. They don't have access to fresh water supplies. So they are even more vulnerable in an urban area because of the urban heat island effect. You're going to be exposed to health issues that it could be quite serious. And so this is another thing that we are starting. So that was turned down. Then turned down the heat report 2. This was focusing again. This was a regional deep dive. Turn down the heat 1 was a global report, looking largely to give us some indications of where some of the major vulnerabilities lay. And here we're looking now at a much more detailed picture. In this case, South Asia, East Asia, and the Pacific, and Africa. So these were sort of really important because in sheer numbers, if you start to look at where poverty is located, it's South Asia and Africa. And the bank's premier goal or primary goals now are reduce extreme poverty, people living on less than $1.25 a day. It's extremely difficult. I've tried this at home, and my daughters gave up on the day one, right? It's extremely difficult. You have no light. You switch off the lights. You turn off the fridge. You do. You see how difficult it is. The goal of the bank is get rid of that as soon as possible. So it's a major task, and not only get rid of that, but then share the prosperity. Some people are very wealthy, some less. Can we somehow make a system that's more equitable for people? Very, very difficult. And the conclusion of Turn Down the Heat report, when we first met with the president of the World Bank, Professor Sheldon Huber, first thing he said to him was, Mr. President, be prepared for the possibility, fairly high probability, that climate change will roll back 3 to 4 decades of World Bank achievements in development. And that was a shock. Okay, it's not just going to impact going down the road, but people are going to get worse off over time. So I think how are we doing for time, Goodney? I don't want to. Okay. So this idea that we are at a crossroads. Kevin's highlighted it. Kevin's going to highlight it even more clearly. And in essence, these two RCPs, these are sort of, I don't want to use them scenarios, but this is what ICC is talking about. In essence, you're looking at a 4-degree world, 8.5, and that's around a 2-degree world down there. But you see that if we want to get on that 2-degree world, we don't really have too much time to sort of drastically reduce emissions, because it is emissions, greenhouse gas emissions, that are causing much of this. We've talked a little bit about this, but we were getting a bit more data now in 2. Again, you see 2-degree, 4-degree. It doesn't look good. That's why we're saying it's a different planet, sea level rise. Okay. Frequency of storms go up, heat events go up. Sub-Saharan food productivity is likely to be impacted. Major biome shifts, grasslands to woodlands, woodlands to something else, fire regimes, and so grazing, which is such an important issue for many communities in Africa, could suddenly change, could suddenly look very different. Their livestock might have not enough access to. This is beginning to sound rather gloomy and doomy, but I'm just presenting what we found. It's not my fault, but again, aridity, we can see that largely 2 degrees on the left, 4 degrees on the right. Southern Africa, that's a major breadbasket for Africa, it's getting drier. That's going to be a problem. Eastern Africa, where I come from, is going to get wet. So when I show this, the local politicians get really excited. They say, yeah, we're going to get more rainfall. But I said, okay, now remember the last time in the ENSO, El Nino, La Nina event, you got more rainfall? What happened? You lost the main Nairobi to Mombasa road, you lost your railways, you lost half your bridges, so your landscape isn't ready for 20% more rainfall. So either way, you have to get ready. And this is where we sort of begin to talk of resilience building. There's climate information, but there's a lot we can be doing. So this is where we are starting to operate. This is what I do. How do we prepare communities and farmers and foresters and people in cities and all to begin to address some of this? There's no technological fix. Kevin will talk about this. There's quite a lot in terms of social resilience. In the big heat event in Chicago some time ago, they found that some communities really suffered. There were deaths. Several hundred people died in some communities and others they didn't. And it turned out that the communities that had not suffered as much in the heat event were the Afro-American and the Latino communities. And they said, what the heck's going on? How come all these power neighborhoods, and these... Turns out that the social resilience in the Latino and the Afro-American communities is much greater. The people know each other. If Mrs. So-and-so doesn't show up to pick up her bread in the morning, what happened? Why didn't she show up? Go check on her. Knock on her door. So, it's very interesting. Is this social resilience, this connectivity among communities. And in Iceland, you have rather small communities. Each one knows each other. And it's easier. But in the big pulsing metropolises of the West, it's tough. You barely know your neighbor very often. You're working the whole day, you don't. And so this begins to put up some flags. In Sandy, something similar happened. The neighborhoods that recovered the soonest were the neighborhoods that had social action. People that got out, started providing meals, water, started looking out after neighbors who were ill, etc. And those that didn't took a long time. Okay, so I don't want to belabor that fact, but it is an important thing. We've talked about agriculture productivity, but again, one thing here that struck us was that by the 2030s, 40% of the current maize cropping areas in Africa could be unsuitable for maize. Maize or corn is the major food crop for Africa. 40%? What's going to happen? Well, we know what's going to happen. There's going to be major social upheaval. There's going to be many more people getting on boats, okay, and this is humanity trying to survive. East Asia, we had similar we focused largely on the temperature, on sea level rise, heat extremes on the left 2 degrees, on the right 4 degrees, really dramatic changes. You see here, it goes way up 60 to 70% of the land area. Here are around 50%, even 50% of the land area impacted by these heat extremes is pretty dramatic if you're living in a city without air conditioning. The coral reefs we've talked about, but at 1.5 you see largely all the coral reefs in East Asia are gone. Somehow the Caribbean seems to hang on. I guess it's part of the temperature regimes there and acidification. But by 2 degrees or later, actually by 4 degrees, all the coral reefs are gone. And that's huge for fisheries, it's huge for physical protection of coastlines, it's huge for livelihoods. The dive tourism in the Caribbean alone brings in the $3 to $4 billion a year. Okay, so all that goes down, and this is something similar sort of crop impacts. There is a ongoing debate about carbon dioxide fertilization, CO2 fertilization. So as CO2 in the atmosphere goes up, the hypothesis is, and the plant physiological data suggests that you might get increased productivity because there's more carbon that the plants can fix. There are, however, other negative impacts that can happen at the same time. So plants will also adapt in the way their physiological mechanisms respond. Okay? So we're not sure about this yet. This is a major one, is that we're beginning to see a trend, not insignificant trend, that the southwest Indian summer monsoon could suddenly decline. Now you've got what, 1.2 billion people in India depending on the monsoon? And if that shifts, that's a problem. Again, we're not certain, but there is some data starting to show up. Potsdam is starting to look at this, and some of the local observations suggest that it may be true. You know, you can read these reports. I recommend you read them. They're written in a style that's easy to understand. It's not an IPCC report. It follows that, but and it builds on IPCC. So for us, IPCC is still the gold standard in terms of science. We don't pretend to substitute an IPCC science-based report. But Potsdam, who provided this, is a key partner in the IPCC process. So I mean, and you've talked. I mean, Steven Ramstoff has been here as well to talk about it, and he's one of the team that worked on that. So, but it's written in a way that's relevant to you as individuals, as families, as communities, and it's important now that you realize, even though you're in Iceland, as we're showing, these global projections and global impacts can come, and they will impact you. I think we talked about regional tipping points. I don't want to focus too much on it, but we are beginning to see, because of the monsoon impacts, because of some of the agricultural impacts, we're beginning to see some major impacts on a global food system. So you'll recall when in a La Nina event in Ukraine, the wheat yield declined by 20%. The first thing they did, and Russia also took a hit, and Ukraine took a hit, and the first thing they did was to prohibit exports or limit exports. And that set a wave in the markets that created a food price increase that was quite unprecedented. Okay, they say today that much of the social upheaval we saw in the Middle East and all was linked somehow to that wheat price, because bread became impossible to buy. And that triggered some pretty serious issues. We think there was not just wheat. I focus a lot on rice, because I like rice, because rice is the small grain that feeds about 4 billion people. Okay, and at the same time there was something happening to rice, and we didn't pick it up. But in retrospect, rice might have been another big trigger, coupled with the wheat shock, that really hammered it, because if 4 billion people suddenly feel threatened, then we have an issue. So you see how you have to keep this broad connectivity in mind. Okay. These are these 3 sigma events that people refer to. 3 sigma is 3 standard deviations away from the mean. In statistical terms, that's a 1 in a 700 year plus event. If they start occurring every decade, we have a problem. The 5 sigma events, Kevin showed one of those 5 sigma events the other day. I mean, that's 1 in a several million year event. We don't want those. So in a distribution, instead of being very thin-tailed in your statistical distribution, those tails start to become real fat. So mathematically, you'll know what I'm saying, and that's a problem. Those fat tails, society can't deal with, especially the smaller countries. Okay, so this is Turn Down the Heat 3. So this was the deep dive into Latin America, Middle East, North Africa, and Europe and Central Asia. The Balkans and Kazakhstan, Kyrgyzstan, Central Asia. Heat events, again, very worrying. This is for Latin America. You can see 2 degrees, 4 degrees. We started plotting the recent disaster information that's coming out of insurance agencies. It doesn't look good. The insurance industries are getting real worried. Now, I'm not saying that this is being caused by climate change, but the insurance industries are going to get bankrupt if this goes on, or nobody's going to be able to afford the premiums if they're going to be viable. Okay, so this helps us sort of in the dialogue with our clients. I put this here because this talks about fish catch. Now, Iceland is a major fishing player, and you see that there's impacts all the way up, huh? But the bulk of the impacts are concentrated, as you can see there, around the tropical zone. We don't understand all of this yet. We're beginning to see certain impacts, and this could be a problem. Now, Rax is there. I mean, he's been seeing that stuff in Greenland, he told me. Okay, and so we are beginning to get a bit worried, and the papers that are emerging on plankton, on sea organism distributions are quite dramatic, in the sense that not only are the fish moving away from warmer temperatures, so you're seeing new fish. I think some of the Scandinavian fishermen were sort of saying they're catching stuff that they've never seen before recently. But whether that's just an erroneous event, or whether it's something that is persistent and consistent with what's happening in the ocean temperatures, I don't know. But it's something to keep track of, because a lot of livelihoods depend upon it. If it's linked with coral systems, you have a problem too. Now, there's one thing that's emerging as well for us, is that some areas are going to benefit from climate change. Let's not just paint gloomy pictures on this. So as fish move, some people are starting to say, hey, wait a minute, we're starting to see some cool fish here. There's a market for this. And so some of them, I don't know whether that's going to be permanent, or whether that's going to be relevant in terms of economic systems, but it's something important to state, that it's not all negative, negative, negative. There is evidence that there are positive impacts, but they're relatively few at this stage. Water is the big story. You can see largely we're projecting discharge rates in major rivers and all are going to go down. Certain areas get wet, but they also have a problem because they can't deal with the extra water. And so you have to know where this is going to happen. We're finding that not necessarily number of cyclones, but the number of intense cyclones are going to go up, especially in the Caribbean. Now, if you look at Central America, I have a plot. I think I should move to that, because I'm going to show you stuff that we're looking at with our clients in Central America or Latin America. This is something I'm dealing with in the Amazon. So 2005, 2010, the Amazon had 2 mega droughts. There's about 100 million hectares at the southern margin of the Amazon, that brownish stuff that you see, that hasn't recovered from this mega drought. So what does it mean it hasn't recovered? The trees, a large number of trees are dead, standing dead. If they have a fire, I was saying to the local politicians, what Schwarzenegger faced in California will look like a small picnic. Okay, just given the number of amount of biomass that's standing there. The drought alone in 2005, by work by Brazilian and other scientists, I think the UK Met Office was involved, suggests that 1 petagram of carbon came out just from the drought. So now I mentioned this to Kevin. He says I'm going to have to redo some of my projections. I don't know if that's true or not, but I mean this is published in PNAS, the Proceedings of the National Academy of Sciences. Okay, and we're seeing this at the southern margin. It's no longer called dieback, but it is Amazon degradation. And this Amazon is a big water pump. It pushes out enormous amounts of water. Latent heat changes as the water goes to water vapor, drives, if you like, circulation across the region, across the globe. So anything that happens here could be important. We are now finding Sao Paulo, Brazil's mega city, 21 million people. 10 million people don't have water today. They're in a mega drought. And Brazilian scientists are suggesting that a lot of the water that comes to central Brazil, southern Brazil, Uruguay, maybe 30-40% originates in the Amazon. So if the Amazon is retreating, somebody's turning off the tap for Latin America. 95% of Brazilian agriculture is irrigated. Brazil is in the top 5 of the major commodity exporter today. If 95% of your agriculture is irrigated and you're getting that kind of impact on water, you have a problem. 80% of Brazil's energy is hydropower. So you can begin to see the issues here. So something we're discussing, and this is an idea, now we're trying to put this together with our Brazilian colleagues and communities, is can we put a green belt in at the southern margin of the Amazon to sort of hold this back? This is sort of not geoengineering, but this is cool stuff. This is, putting in native species that are resilient to drought, putting people in there, eliminating fire from that southern margin, really sort of doing this by science. Sort of people are excited about it. Africa is already doing a green wall, southern margin of the Sahel. And it's not planting trees, but it is ecosystem landscape scale management. So you look at hydrology, you look at biology, you look at science, climate science, and you put together a livelihood system that are resilient to these kinds of shocks. Okay, so this is ongoing. That's why I'm showing you this. I talked about the storms. These are this is Central America. These are tracks of hurricane Cat 4, Cat 5 that impact Central America. So I often refer to this when I'm talking to the politicians as two drunk giants playing bulls. Okay, you've got one in the Atlantic, one in the Pacific, and those, for some reason, they're missing the target. But last year, the giants got sober, and Mexico took a simultaneous hit. And Acapulco Airport, this is a major international airport, was neck deep in water. They lost the major road between Acapulco City and Mexico City. This was 5-lane highways. Okay, so we are not prepared to take on these kind of extreme events. And if the science is projecting that we're going to get more of the extreme events, not necessarily more hurricanes, but more of the extreme events which are likely to make landfall, then we have a problem. So that means you have to start to redesign your infrastructure. You have to take that into account when you're doing. This is all the hurricanes for that part of the world in a 10-year period, okay? 2000, 2011. And anybody can do this. You can go on the NOAA site and you can plot it and you can put in your variables. The politicians had never seen this till we presented this to them. It was kind of really interesting to see their faces when they looked at this. Okay. I plotted out, this was that grain shock that I was telling you. I plotted out for the Ukraine just some of the data on grain and just looked at what had happened in that period, 2008, 2013. We had back-to-back La Niñas in that time. You can see this grain shock was global. It was the equivalent of 25 million metric tons of grain per year loss just from the climate impact. That's a major food shock. Okay. So I think, I'm not saying this happens every year, but this was just to sort of highlight why it's important. Some of the data that we have projected, this is a study we did in the bank looking at crop impacts. You see that corn, soybean, and wheat take major negative impacts. Rice comes out positive, which for Latin America is exciting because Latin America is a net importer of rice. The big producers of rice, China and India, eat everything they produce. The global exporters of Vietnam and Thailand, they're facing some pretty major impacts in the Vietnam Delta. So Latin America could, in essence, take advantage of this, is the theory. We're taking a hard look at this. We're working with communities. We're using big data analytics to inform communities how to plant rice. And we've had some very, very interesting successes. Farmers are getting very excited about it. We think in the next year or two we'll have a large number of farmers in Latin America that will adopt the latest science in terms of rice cultivation. Latin America currently produces 4 tons per hectare. East Asia produces 10 tons per hectare. So there's a yield gap. Latin America, with the current science, can easily ramp up. So we're seeing how we can, this is the resilience building. Resilience not just for one country, not just for one region, but a global food system. The small grain that feeds 4 billion people. Okay, this is the way we're doing stuff with them. Coffee. If you drink coffee, be worried. Be very worried. Okay, find a substitute. This is what coffee suitability is. Unfortunately, we use red. I mean, this was by CIAT, an international agency that's working there. But you see in Colombia, Juan Valdez basically has migrated by that time. Okay, it's a major problem. The same driver that makes this area of coffee unsuitable is principally temperature as a driving agent for Arabica coffee. Brings in malaria and dengue. So it's a double whammy. Smallholder system, these are not big mega farms, these are smallholder producers. Not only do they use their principal livelihood, they then get exposed to diseases that they haven't really been exposed to before. Okay, I think we're out of time, but yesterday I saw the northern lights or the aurora borealis, so I had to put it into this image. It was fabulous. Yeah, it was something new that I had never seen before. Now I want to do one more thing for you, because I'll show you, yes, we are talking about climate. So this is the kingdom of Bhutan. I don't know how many of you have visited Bhutan. Yeah, it's an amazing country, right? It has gross national happiness index, and they take that very seriously. But it's a beautiful country. It's the Himalayas in the background. You can see that there. Right here, this is the Himalayan chain. That's China, Tibet. This is Bhutan. This is India here. 60% of Bhutan's GDP comes from hydropower sales to India. 60%. It's like fishing for Iceland, I guess, right? And they rely on flows from, there's no reservoirs there because of the terrain. This is pretty steep terrain. So this is, a digital elevation model produced by NASA, as you can see there. This is easily done. But what we've done is we've taken the same variables that drive the climate models, precipitation, temperature, etc., put them into hydrological models that are in nested scales. And now we're trying to do this globally. So we're taking climate information and saying, okay, what do the climate models agree on or disagree on? Use those as extreme envelopes and put them down in a real landscape in a hydrological model to see how that happens. I want to show you what happens for Bhutan and how we're showing this to policymakers. So this is real data. This is not a simulation. This is real data in a real landscape for 2006. And at the bottom here, you can see January, February, March. So we're plotting this. You're running this at monthly intervals for this country. What you're going to see is on the right, you see the rainfall, the blue, the evapotranspiration in the purplish color, and the surface runoff, the green. So each little dot that you see there is a real pixel. We're running this at 15 kilometer pixels. Now, does this make sense? Well, we can check because we can measure the flows in the rivers. Does it make perfect sense? No, it doesn't. But this is where we are now. This is how we are using climate in a real sense to actually help people to get ready. We demonstrated this to the Prime Minister, and he called in 4 of his ministers and says, why are we building a road which this model says is going to be inundated for 5 months of the year in this particular area? He asked them the question. They said, yes, Mr. Prime Minister, we are aware of this, but this is how we are mitigating that. So this is the kind of thing that you need to be able to do. This is how we are taking sophisticated climate data and making it real for our policymakers. And unless you do this, it becomes very esoteric. People believe you or they don't. So I'll stop there. Thank you very much.